In question 30, we've got a geometric series. Now we've got a couple of clues. The sum of the first two terms is 45 and the third term is 12. Show that there are two possible sequences and find the common ratio and the first term for each one. Now, a couple of ways that I can think about going about this. My first impression is to say, well, we don't know what the first two terms are. It'd be handy to have some expression for them. So we could say, let the first two terms be whatever you like. Let's go x and y. Okay, so if they're x and y, then one thing we know is that x plus y is going to equal 45 because we've got that as a clue. The other thing we know about a geometric series or a sequence is that the third term divided by the second should be exactly the same as the second term divided by the first. So if we know that the third term is 12, then we can say 12 divided by the second term must equal the second term divided by the first term. And if I tidy this up, that gives me 12x is equal to y squared. So I've got two equations here, and now I can just solve them simultaneously. So logical way to do it would be to say, therefore, x is 45 minus y. So now I can sub that in. So we've got 12 multiplied by 45 minus y is equal to y squared. And expanding this out now, I'm going to end up with y squared plus 12y minus 540 equals 0. Now, this is factorizable. We'll keep going over here. We can do y plus 30 and y minus 18. But if you couldn't easily factorize that, you could just throw it into the quadratic formula using a is 1, b is 12, c is minus 540. So y could potentially be minus 30 or it could be 18. Now, there was a hint that there were two possible sequences, so it makes sense that we've got two answers. Now I would say when y is equal to minus 30, what would x be? We'd have x minus 30 is equal to 45, so then x would be 75. And when y is equal to the other option, 18, we would say that x plus 18 is 45. So, so x must be 27. So we've got two options there, but we've got to be careful not to stop there. We haven't yet answered the question. We know now two options for the first two terms, but we've got to find not just the first term, but the common ratio. So if x, let's just list it. First option is that we've got x is, let's say, 27, and y, which is the second term, is 18, and the third term we know is 12. That would be the first series. And this series says the first term is, oh, well, it doesn't mention a, does it? We'd better actually write down first term 27, and the ratio, well, the ratio is what you need to multiply each term to get to the next one. So you find it by doing one term divided by the term before. And this gives us 18 over 27 or 12 over 18. Either way, it's 2/3. Now the second option would be to say what is the series, and I think it's handy to write it out so you can see it. When x is 75, y is minus 30, and we know that the third term is 12. So either 12 over minus 30 or minus 30 over 75 gives you the same thing. So in that case, the first term would be 75 and the ratio would be negative 0.4, or you could write it as negative 2/5. Now, another way that you could think of doing this, instead of using x and y to be the first two terms, is you could actually just use the formula for the nth term of a geometric series, which we know is this. And you could kind of think through, all right, the first term is just a. The second term is a multiplied by that common ratio. The third term is a r squared. Now, having a little algebraic expression for each of these terms helps you a lot, because for a start we know that AR squared is 12. We've been told that. But we also know that the first two terms, when you add them together, gives you 45. So here, now I've got two simultaneous equations that I can solve. And this way is probably even nicer, because rather than finding what the first term is and what the second term is, this is going to give me the first term and the common ratio just like that. So I then have to reason what the second term is and just make sure my answer made sense. But this method is potentially even nicer. Now I'd probably start by just, well, there's lots of ways you could do it. You could let A be the subject in both of these, factorising the second one, let them equal each other. Or you could let A be the subject in this one and then sub it in. But however you solve it, you need some way of getting started. So if you looked at this question and you felt a little bit stuck, both of those tips might help. Either make an X and a Y or something like that for those first two terms, so then you can think what they are, or just write down what you already know. Once you've listed a few things, then you realise you can start piecing it together and working with it.